Okay, so think back to the last time you were really trying to learn something, maybe like a new piece of software,
Hmm.
or trying to wrap your head around a complex idea.
Or even just, where you left your keys like 5 minutes ago. Happens to me all the time.
Right. Well, here's a wild thought. What if the real learning, the bit where it actually sticks, doesn't happen when you're laser focused, but
Yeah.
actually while you're asleep?
That's exactly the really fascinating puzzle we're digging into today. There's some, well, pretty compelling new research coming out in neuroscience,
What?
and it's showing just how incredibly active our brains are when we sleep, especially when it comes to learning and memory.
Yeah, and there's one study actually that really caught our eye. It's from the University of Toyama, published in Nature Communications, like super recently, April 28th, 2025.
That's the one. And it gets into some really novel territory about what the brain's up to while we're out, dreaming or not dreaming. It's busy.
Okay, so the mission for this deep dive then is
Yeah.
basically to unpack why sleep isn't just, switching off the lights upstairs.
Exactly. It's fundamental. It's this dynamic process that's absolutely essential for learning. We want to look at how it helps, like lock in what we learn,
Right.
build on skills, and even get us ready to soak up new stuff later on. Think of it as maybe a shortcut to understanding this vital brain connection.
And this matters for pretty much everyone, right? Whether you're a student or trying to upskill for work, or maybe you're just curious about how your own brain ticks.
Absolutely. Understanding this sleep learning link, it's potentially a game changer for how well you think and learn.
Okay, so let's start with that first big idea. Sleep isn't just rest, it's active.
Right. The old view was kind of like sleep is passive, just recovery time for the brain after a long day.
Yeah, like putting your computer in sleep mode.
Sort of,
Yeah.
but the science now paints a very different picture. It's not inactive at all. It's a period of really intense processing. One source actually put it really nicely. Sleep is not just recovery time, it is active processing time.
Active processing time. Okay, that sounds like work. What's the brain actually doing during this active sleep?
Well, a huge part of it is memory consolidation. During sleep, especially in the deeper stages,
Like deep sleep, slow wave sleep, and REM.
exactly, slow wave sleep, which is that really deep, restful kind, and REM sleep, where we tend to dream more vividly. During these times, the brain is actively strengthening the memories you formed while you were awake.
So it's like taking notes during the day,
Uh-huh.
and then overnight, the brain decides which notes are keepers
Mm-hmm.
and like files them properly, converts them into permanent files.
That's a great way to put it. It's totally critical for actually remembering what you learn long term. Not just for tomorrow's test, but, really remembering it.
Okay. Okay, they get the saving the file idea. But you mentioned it's more than just storing individual facts, right? It's about connecting things.
Precisely. It's not just saving isolated bits. Sleep is also crucial for integrating that new stuff into your existing knowledge network. So it's organizing it, yeah, but also reinforcing the connections to what you already know, making those links stronger, easier to access later.
So that helps with recall. And maybe even those aha moments later on, where suddenly things just click.
Exactly. It's like a librarian, maybe. Not just shelving a new book, but also adding notes in the catalog pointing to related books.
Cross-referencing it.
Yeah, cross-referencing, so you can find it easily and see how it fits into the bigger picture of everything else on the shelves.
That makes a lot of sense. Our brain, this super efficient organizer, working away while we're completely out of it. Amazing.
It really is.
And then there's this idea, which is really interesting, that it's not just organizing, it's selective. It prioritizes certain things, like a nightly filing system with VIP files.
That's right. The brain doesn't seem to treat all information equally when it comes to consolidation. During sleep, it appears to prioritize information it flags as, well, important.
Important how? Like stuff you focused on more.
That could be part of it. But what's also fascinating is that memories linked to strong emotions often get selectively reinforced too.
So if something really grabs you emotionally,
Yeah, if you're really engaged or interested, or if it was a significant event, the brain seems to give that information extra processing time during sleep.
which kind of highlights why just passively reading something might not be as effective as actively engaging with it, right?
Yeah.
Emotionally or intellectually.
Absolutely. It suggests that engagement really matters for long-term retention, and sleep helps cement those important engaging experiences.
Okay, this is where that University of Toyama study comes in, isn't it? Because it sounds like it adds this whole other layer.
Mm-hmm.
It's not just about looking back at what we learned yesterday.
Exactly. That's the really exciting part. For a long time, the focus was mostly on this retrospective role of sleep solidifying the past.
Right, consolidating yesterday's memories.
But this new research from Toyama using mice points to this amazing dual role. They identified these specific brain cells, neurons, which they gave this great name, engram-to-be cells.
Engram-to-be cell, I love that. Okay, engram relates to memory traces, right? So these are like memory traces in waiting.
Pretty much. And what's groundbreaking is what these cells do. They found these neurons actually synchronize their activity during the sleep period after the mice had a learning experience.
Okay, synchronizing,
Yeah.
like getting in tune with each other.
Yeah. But here's the kicker. This synchronization isn't just reinforcing the memory of what was just learned. It seems to be actively preparing these cells to encode totally new experiences in the future.
Whoa, wait. So while my brain is filing away yesterday's stuff,
Mm-hmm.
it's also getting ready for tomorrow's learning,
Yeah.
setting things up.
That seems to be the implication. It's like the brain is multitasking during sleep, dealing with the past and prepping for the future.
That's incredible. So the analogy you used earlier, the filing cabinet, it's like the brain isn't just filing yesterday's papers, it's also setting up new, empty labeled folders for tomorrow's work.
That's a fantastic analogy.
Yeah.
Proactively getting things organized for future learning. And they also saw more coordinated activity, more co-activity.
Between the old memory cells and these new
Mhm.
to-be cells.
Exactly. Between the existing enneagram cells, the ones holding the past memories, and these engram-to-be cells, it suggests there's some kind of coordination, maybe even a dialogue happening during sleep.
Wow. Like the brain is saying, okay, based on what we learned yesterday, let's get these circuits ready for related stuff tomorrow.
Something like that, yeah. Shaping the networks for future memories, potentially informed by past experience.
Okay, mine's slightly blown. How does it do that, though? How does the brain actually manage this prep work for future learning while it's also busy consolidating the past? What are the mechanisms?
Well, this study gets into some of the neurobiology, pointing towards things like synaptic depression and synaptic scaling during sleep.
Okay, starting to sound a bit technical.
Yeah, let's break it down simply. Think of synaptic depression as maybe selectively weakening some connections between brain cells, kind of clearing out clutter maybe, making space.
Okay, pruning away less important connections.
Sort of, yeah, to make room for new strong connections later.
Okay.
And then synaptic scaling is more like a global adjustment, like turning down the overall volume on all the connections just a bit.
Why would it do that?
To keep the brain balanced, basically, to make sure it stays sensitive enough to actually learn new things effectively when you wake up. It prevents the connections from getting too strong overall, which could make it harder to learn.
Ah, okay. So weakening some specific connections, adjusting the overall sensitivity, and these processes help get those engram-to-be cells ready.
That seems to be the idea. These mechanisms working together during sleep appear crucial for priming those engram-to-be cells for their job of forming new memories later on.
Right. It's like overnight maintenance and optimization.
Right.
Making sure the brain is tuned up and ready for the next day's input.
Exactly. It really reinforces this picture of dual processing happening while we sleep.
Dual processing.
Yeah.
So two tracks running at the same time.
Yeah. On one track, you've got the strengthening, the conservation of past memories. That's the reactivation of the original enneagram cells.
Okay, the looking back part.
Right. And on the other track, running alongside, you've got this preparation for future memories, driven by changes in the synapses, that plasticity, and getting those engram-to-be cells online.
So sleep is much more forward-looking than we might have thought. It's not just archiving.
It seems that way. It's dynamic, it's dealing with the past, and it's actively anticipating the future.
This is, just fascinating science. But let's bring it back home. Why does this matter for, you listening right now in your day-to-day life, trying to learn stuff?
Well, the practical benefits are really significant. This research just hammers home that getting enough good quality sleep isn't a nice to have. It's non-negotiable for effective learning.
It's not a luxury.
Not at all. When you prioritize sleep, you're not just going to remember things better.
Right.
You'll also likely be better at solving new problems, applying what you know. Your overall cognitive performance gets a boost.
Which means pulling that all-nighter to cram. Probably not the best strategy.
Yeah.
Even though it feels productive at the time.
It's almost certainly counterproductive in the long run. Yeah. Our sources really emphasize that the sleep between learning sessions is critical.
Between sessions, right?
It directly impacts both how well you lock down what you just learned and how ready your brain is to absorb new information the next day.
And skimping on sleep.
It just messes things up. weakens memory consolidation, makes your decision-making fuzzier, harder to actually use the knowledge you have. It impacts performance across the board.
Okay, so let's talk takeaways. For anyone listening who's, actively learning, student, professional, lifelong learner, how can we use this knowledge to learn smarter, not just harder?
Well, the first thing is maybe a mindset shift. Think of learning as this continuous process that doesn't stop when you close the book or log off the training module. It literally extends into your sleep.
Right, sleep is part of the learning process itself.
Exactly. And second, respect your brain's limits during the day. Cognitive load is real. Don't just cram relentlessly. Allow for breaks, allow for downtime, and recognize that sleep is the ultimate recovery and processing window.
So that old advice, get a good night's sleep before the exam. There's real science behind it, more than we probably realized.
Absolutely solid neuroscience. And when you start respecting these natural brain rhythms, you can see the practical benefits.
Like what?
Well, potentially better retention with maybe less overall struggle, because you're letting your brain do its consolidation work efficiently. You might find problem solving improves, you master new skills a bit faster.
And you mentioned learning tools.
Yeah, things like spaced repetition, where you revisit information at increasing intervals. Those techniques likely work so well, partly because they give your brain these sleep cycles in between to consolidate the information effectively. They work with your brain's natural nightly processes.
This has been, really eye-opening, just reframing sleep completely. It's not downtime, it's essential active learning time.
It really is. It's amazing to think that while we're just lying there, hopefully resting peacefully, our brains are doing this incredible double act, archiving the past and preparing for the future.
So, a final thought for everyone listening. As you're drifting off tonight, just consider that. Your brain isn't shutting down.
Yep. It's busy organizing, consolidating, and actually getting ready for whatever you're going to learn tomorrow. What new connections might be firing up, getting ready, even while you rest.
It's a powerful thought.
Yeah.
It really drives home that valuing sleep isn't just about feeling less tired. It's a fundamental tool for boosting our learning, our memory, our overall brain power.
Exactly. And just understanding these basic processes, how our brains actually work when it comes to learning and sleep, well, that can help us find much more effective, maybe even less stressful ways to learn and grow.